the first task we have to do. And now based on this, first library I'm importing is import numpy as np. We discussed this library yesterday as well. Second library I'll be using is pandas as pd. Then two visualization libraries that I disclosed yesterday also. So matplotlib.pyplot as plt. And last one we have is cbon as sns. These four libraries at initial level I'll be using, and if I need any other library later on, that we can attach as per the requirement. So let us run this part, and then I'll be sharing this code. So I have dropped this code on your snipper window. All of you are requested just to copy paste from snipper window. Do not edit it. Do not cut paste anything. That will be essential. Otherwise, everyone will lose some text out there. And keep on updating your status in the chat box. If you are stuck anywhere, you need any help, then also let me know. So we have imported some necessary libraries, and we can see the green tick mark in front of your execution cell, and it means that this is working fine, and we can see that this code is well uh, compiled over here. The second task we need to do is load dataset. So since we are doing here some visualization task, we definitely need to get some data set right here. And because we are still on some basics, we are still trying to clear some basics. So instead of getting any major data set, we'll again start with some CSV files that you all must have received for day 2 analysis. The zip folder must be with all of you that contains 2 files. One of those files you must have seen yesterday also, that is diabetes dataset. And the second dataset is also from the medical field, that is your SAHD dataset. Two of these datasets will be using. Just on and off, just to see different variation, just to plot different things. Otherwise, you can try the same things later on with other data sets also. The idea is to learn the concept and then try to build something based on that essential knowledge that we get from it. So in order to load data set, what we have learned yesterday, the same procedure we are going to follow. So we need to first upload your data sheets, that we can do by using this files option right on the left side corner. I hope all of you remember it from the yesterday also. So I'll just click on this files option. And as we know, we have two techniques. Either we can drag and drop, or we can click on upload button. So if all of you have your dataset accessible easily, then we can drag and drop it from the folder right here. So in my case, I have both these datasets in a folder, so I can drag and drop. All of you just get your datasets ready on the platform and let me know in the chat box when you are ready with it. You should have these two datasets as CSV files loaded over here. I'll wait for the responses in the chat box, everyone. I hope the chat window is enabled for all of you. Snipper link, if you are looking forward to get it again, I'll put it here in the chat box. Those who don't have it already, they can get it from there. I'm using this day 2 sheet from here. This one you can use. Thanks for the update in the chat box. This is good to see you people responsive in the chat box. This is because the only way to interact and let me know that you are able to follow the instructions over here. So we are here to now put this data set inside a variable so that we can access it throughout your coding process. Yesterday also we have learned that we can take help from pandas library. Inside that we have read csv function. So we'll first read both the data sets, and I'll use keywords for this. Like the first data set I'll read in this, and second data set I'll read inside this variable. Two of these I have created. You might be aware that while working on this, you may need connected words to declare your variables. There should not be space between variable declarations or variable names in Python. So that is why we are using it with this underscore. Or you can choose any other name, but just make sure you use it consistently throughout the code. So the first part is to read CSV file. And inside this bracket and inverted commas, we need to put address of your file that we have learned yesterday also. So simply go to your data file, right click on it, and then copy path and paste it here. Same we need to do with the other data set as well. So read CSV inside this. I'll again copy path and put it right here. So the two files now I have updated. I'll run this code, and you can see the green tick mark in front of this. It means that this is working fine and we are ready with the data set. So I can put this code in the chat window, right in your snipper window as well. You can get it from there. Make sure you don't have any unwanted indentations in your code, otherwise it will lead to some error in Python. Once you have loaded your code, we can just try to see first few lines of this code by using head command. This also we have learned yesterday. The head command basically tries to display the first few lines of your data. So this is one of the data sets, and same I can do for the second data set as well. So I'll use here the head command, and we'll visualize both these data sets. You can see one is related to diabetes and other is related to a class based on all these categories, whether they are leading to the disease or not. So again, this is with 1 and -1, two categories. And this one is with 1 and 0, two categories. This is your mainly target variable here, outcome, and this is the other target variable we have in the data set. So this is the initial visualization of your data. Let me know if you all are ready with this, if you are able to get this particular view of your data. I'm inserting this small set of code also in the snipper window. These are always the first essential task you do with your data: to understand its structure, to understand the name of variables contained inside the data, and what type of variable distribution we have, like whether we have continuous variable, whether we have class variables within dataset. So that is instantly clear from this mini view of data. I hope everyone is ready up to this, and this is working fine. Okay, thank you very much for the updates in the chat box. Moving further, let us try, because we are working on visualization and EDA. EDA in data science is one important word, that is for exploratory data analysis. Means exploring every angle of your data related to its stats, its plots, or structure of the data. That becomes your exploratory data analysis, exploring everything about data to understand its pattern, to understand its variable distributions, to understand how one variable is linked with other, And the visualization can be of many types, such as we can have univariate plots, we can have bivariate plots, a single variable distribution we can analyze by using some plots, multivariable analysis also we can use with other plots. So plenty of options are there. Again, in Python you have unlimited functions, you have several different libraries that you can use for this purpose. We are currently working on 4 important libraries, so that will help us to understand the structure right now. First, I'll let you know few quick response based options. A few of them we have used yesterday also, a few new ones also will add over here. This is quick info about data structure. If we have to get, that is a task I'm inserting here. So on any one of these data sets, I'll try to implement it. For instance, on my diabetes data set, you can try it with the other data set as well. So first thing I'll check is shape of this data. And this shape command will help you know number of rows and a number of columns in your data set. So first one is number of rows, second is number of columns. So this is first technique to explore initial information about your data. So we call it rows and column distribution. After this, the next part, I'll share this one in the snipper window as well. You can try one more thing. There is a size option also. For instance, I'll insert here again the diabetes dataset, and I'll try to check its size, and let us see what we get in the outcome. You can see this count, and this basically means the number of entries you have in your dataset. That means row multiplied by column. So total number of entries you have in your dataset is this. Sometime while you disclose information about your dataset, you need this kind of structure. You need to mention these numbers in your research papers, in your thesis reports, just to give an idea of what kind of dataset or what how big dataset you are utilizing in your research study. So that is why we are adding these elements right here. So I'll insert this one also here in the snipper window. One more part with this basic analysis we can have is, I'll add here G types, for example, data types for variables inside your data. So you can see a quick information about each variable inside my data, whether they are numerical variables or they are categorical variables. Both of these we have studied yesterday also. Categorical variables are the ones that come with string kind of values, and you need to transform them. Sometimes they are already encoded. So all those informations you can have, but basically the data type, that is more important. So when we have a numerical data type, that can be of two types, int type and float type. So these two are the most common available in your dataset. Other than this, when you have some string based column in your dataset, that will be listed as an object entry. So string is represented as object entry in your dataset. So that you will visualize by using this data types command associated to your data variable. Let me know if everyone is clear up to this. These are just few basic elements we have discussed by now. I can see some responses. Okay, fine. If anyone is stuck anywhere, they can let me know in the chat box. If you are implementing it side by side, that will be good. After this, statistical structure of data. That is to disclose how the statistical distribution is going with your dataset. And one command of this we have used yesterday also. So let me try the same here for you. Just to recall that this is also a part of data exploration, because we are just trying to gather the statistical structure of data from here. And you can see this information. What it brings to you: total count of values that we have in each variable, mean of every individual variable, standard deviation of every individual variable, the min value inside each one of these. So in this data set, the min value is 0 in majority of entries. Similarly, 25 percentile, this also we have discussed yesterday. 50% is basically median value of your data set. And then 75 percentile also we have discussed yesterday. These are basically the quartiles, lower quartile and upper quartile. And then we have max values available in each variable. So this shows a quick distribution about your dataset. Now we will start further with the visualization techniques. These are just few initial things we have done to explore the text-based information in your dataset. Now we'll put forward details with some visualization. So I'll add here. So this all is going as a part of EDA. Everything that we are doing right from here, I'll write it as a part of EDA. So inside these visualization techniques, again, you will have multiple options. For instance, we have univariate analysis, we have bivariate analysis, and there is multivariate analysis as well. So what we do in case of univariate analysis, as the name suggests, when we are analyzing only one variable at a time, means from your data set, we try to visualize or analyze only one column at a time, just to see its structure, just to understand its pattern. And that we can do by using variety of plots, such as we can have pie charts, we can have bar charts, box plots are there, histograms are there. Depending upon what type of analysis we want to do, there are different options that we can try in this category. Second option in the list we have is bivariate analysis. When we are analyzing two variables at a time to understand whether there is a relationship between both of these or not. A scatter plot can be one example of bivariate analysis. Third one is a multivariate analysis. Bivariate is considering two variables at a time. Multivariate is when we are considering more than two variables. Like in this particular data set, if we have seen the structure like 9 variables, 9 columns in your data set. So when we try to explore each one of them and find relations between each one of them with each other, that becomes your multivariate analysis. And heat map can be one of the most common example of multivariate analysis. So these keywords that I'm calling right now, bar charts, pie graphs or pie charts, or like we have scatter plots, we have heat maps, they are all kind of visualizations. They are different types of plots that we create to understand pattern of our data. So some of these we'll try to create here to understand the Python basics for this and how we follow a specific procedure to create these things. Very first thing I'll add here is correlation analysis. That is one of the most common kind of analysis we follow in your EDA approaches for visualization also. Now, in correlation analysis, what we understand at initial level, if you are aware of this, correlation is basically to understand how two variables are related to each other, or sometimes we do it with a huge set of variables. Like on the entire data set, we try to analyze how one variable is linked to other variable and all. So that relationship we try to establish. And the correlation values generally lie between +1 and -1. That is the common way out. We have a -1 to +1. This is the sequence we follow. -1 shows purely negative correlation between variables. +1 shows purely positive correlation between variables. And when we have 0 correlation in between, that means null correlation. That means the variables do not have any impact on each other. So 3 common values means your correlation can vary between these 2 wide values. So whenever we try to get a correlation between data right here, for instance, I'll take one of the already loaded data set, that such as this SHD data set, and correlation we can calculate by using a very simple technique, a very simple method we have. Just we need to apply correlation function with core brackets. So if I run this one, we'll get a matrix listing relationship between different variables ranging from -1 to 1. But you will see here that we have a graph of, or simply a matrix of numbers. And as a normal human being, it gets little difficult to compare these numbers instantly. We have so many values in front of our eyes, and it gets difficult to track which one is higher, which one is lower. A quick response for this particular data gets difficult, although it is giving you all the values. But as a human nature, we will take some time to analyze which one is higher, which one is lower. And if you have observed the correlation anytime earlier, the correlation matrix, if you have seen anytime earlier, we always have a diagonal element, a upper triangle, and a lower triangle in this particular matrix. Those who are very new to this, let me explain what we have inside. You can see that this diagonal element, this is always 1. Observe this. These entries are always 1. Means highest correlation. And why? Because this is self correlation between the same variable to same variable. You can see this one with this one, value 1. So self correlation of a variable is always 1. And accordingly, it will follow with other variables also, such as tobacco correlation with this SBP variable, or then LDL variable, different parameters of human body that they have measured. Accordingly, they have put a relationship between them. The second factor you have to observe from a correlation matrix, this is diagonal 1. So upper and lower part of this diagonal 1 is purely identical. The second observation from a correlation matrix. I'm explaining this in detail, especially for those who are going to do it for the first time. The upper and lower matrix is truly identical. You will observe this here. 0.21, 0.21, 0.15, 0.15. These values are totally identical. This value and this value. So technically, we call it upper and lower triangle of correlation matrix, and they are purely identical. So instead of looking at entire matrix, we can either look at upper triangle or lower triangle to understand relationship between variables. But even after that, even if I consider maybe only the lower triangle of this particular data set, still it is complicated for an average human being to understand a quick outcome of this particular matrix. Like wherever I have this minus sign, I can say, okay, there is a negative correlation. Wherever we have positive, we can say a positive correlation. But if I quickly ask you that, let me know the variable that has highest correlation with each other, you will have to read these numbers. That is a lengthy process. So a solution to this here comes with visualization technique. This is how the visualization come into role play. We need something in the form of a graph that we can visualize easily in the form of some color, some color coded examples out there, and it will help us to enhance our readability over dataset correlation. So I'll add a solution to this here, create heat map for correlation visualization. One most important kind of graph you will find in EDA. And there is a very simple technique to create correlation analysis with heat map. I'm not sure if we have used it yesterday or not, but still, if we have not used, we'll learn it today here. So the data set, any of the data sets you can use from both of the windows that we have, 2 data sets we have. So I'll use on and off both data sets. So technically, there is this simple way. What I have to do, I need to get my Seaborn library on call, and from there I need to get heat map, and inside this I'll pass the correlation. that I'm getting from my target dataset. So if I run this, I'll get my heat map. But let us see what kind of heat map we get first. I'll tell you everything in a step-by-step manner. This is the heat map we are getting right now. We can see the colorful structure, but there is one problem with this also now. Although the color variations we can identify, I can also tell you that how we decode these color identifications. The brighter one has a different meaning, the darker one has a different meaning. But this is like a blank plot. If you want to make it more engaging or more useful, we can even add the values inside these boxes, like these values. Means along with values we can have color information, both things we can have. So that the first thing is, with color information we can see the highlighted parts, like the minimum correlation and higher correlation we can see quickly with the help of color plot. And second thing, if someone needs value of that correlation, that will be also available from the same graph. So what addition we can do inside this? For this very simple technique, inside this heat map, I'll add one variable, that is a not is equal to true. First thing, I'll add this. Let us see what we get in the outcome. Annotation, I'll make true. By default, it is false, but I'm making it true. So let us see its impact on the graph. If I run this, you can see the values are right there along with the color coding of the heat map. But now, one more problem we can see here. Although we have created values with the graph, but it looks like the figure size is small enough to display these values clearly. We are not able to see them clear enough. To get rid of this problem, we can increase figure size. Since we are learning the visualization techniques here, so we need to understand every aspect of it. So let us increase figure size also. What I'll do here is, I'll write here generate heat map with a specific figure size. So in order to update figure size, we have a specific command available again in the matplotlib. So now for adjusting the figure size, I'm taking help from matplotlib. Sometimes we use libraries in association to each other. That is also possible. So I'm using PLT subplots. Inside this, I'll update my figure size. For instance, I'm using a figure size of 10 by 10. You can change it. 10 by 10 is your width and height of that graph that we are going to generate. Or we can say like how big your figure you want to plot. Accordingly, the size you can mention over here. So this is the information I have added to increase my figure size as per the requirement. Now, this information I have to attach to this heat map. And how I'll do that attachment? This AX, this axis information I have to update inside my SNS plot. So AX parameter equal to AX. This AX value I'm getting from here. And this AX is the actual parameter available inside my heat map. So I'm just mapping it to my declared AX value. If I run this, let us see what we get. Now you can see a bigger and cleaner heat map. Now we can understand it easily. And there is even one more option. You can even change color of this heat map. For example, I'll add here one more variable, CMap, and inside that I'll update. CMap means color map. What kind of color coding you need in your this heat map. So by default, it is following this darker range. Let us add other color option like cool warm. I'll run. You will find thousands of different color options that you can explore later on. So this one I can see a brighter one option with a different color coding sequence. I have shown you all the variations possible with this code. So I'm just inserting it right here. Before this, you can even calculate correlation separately, that I'll write here. First, let me know if you get this graph, this particular figure. Once you get, then I'll explain what we have inside this figure. Or if you are already aware how we use this heat map, then also you can let me know in the chat box. Then I'll not explain this in detail. If anyone wants me to explain how we read this heat map, then I'll do, definitely. I'll wait for the responses in the chat box.
Ma'am, is there any significance of writing a particular value on a particular cell?
Which cell you are saying, ma'am?
For example, in the first row, there is 1, then 0.21, then 0.18 and all. So they are in
Ma'am,
a particular sequence.
ma'am, we are not writing these values. These are the correlation values we are getting from the data set. So I can understand that. It means I need to explain the graph to all of you.
Yeah.
If this is a question, no problem. Let me just take this graph to whiteboard and I'll explain it over there, what we have inside this. Thanks for asking this question, and I hope many others will also need the answer for this. So now what we have here, I recently explained you that we have correlation values that vary between this -1 to 1. We are trying to check correlation between different variables over here. That is, we are getting with this particular figure. You can observe here, the first observation will start with this. You can see on the corners here the names of the variables. This side also you can see names of the variables. First observe this thing, all of you observe this thing. The dataset has these variables and these are aligned here on the x-axis and y-axis of your graph. They are basically depicting your correlation with respect to other variables. That is why they are aligned on the x-axis and y-axis. Now, how we read this heat map, that we need to understand. I told you that on the heat map or in the correlation matrix itself, we have a diagonal element, we have an upper triangle, and we have a lower triangle. From that number-based matrix, it was not so clear, but now here you can understand it easily. What kind of relation we have is this kind of diagonal element. Then we have one upper triangle, and then we have one lower triangle, and they are both identical. Now, this identical means, see what we have here. Let us observe. You will see this first value is exactly equal to this value. This second value is exactly equal to this one. Similarly, this value is exactly equal to this one. So this is how upper and lower triangles are identical to each other. That is why I already told you that either we can proceed with the upper triangle only or we can proceed with the lower triangle only. Any one of these will read. Other is just identity of that. So we can use only one for our analysis. Sometimes we even create half of this graph. That also you can do in by adjusting your code, that it will not display both triangles, it will display only one triangle that is of your interest. So now let us decode the one part of the triangle. Other we need not to worry about because that is depicting the same thing. What we have inside, for instance, if I consider this lower triangle as my relevant thing, this first entry, this one, everyone see this carefully, what we are doing here. This first entry, make relation x-axis and y-axis wise. SBP here is being related to the first element of your x-axis. That is also SBP. That means self correlation between SBP and SBP variable. If you are working on the diabetes data set, maybe the first column will be pregnancies column. So that will be showing you self correlation between pregnancies column. That is why this is always one, because self correlation of a data set is always one. Same you will see with this. See this entry, tobacco on the second line, tobacco on the second line. It means self correlation of the tobacco variable. That is why it is one. Same goes with the next LDL variable, LDL variable. So this third diagonal element represent self correlation of LDL. That is why all these diagonal elements are one. This is the first thing we are understanding. Highest correlation will always be there with the variables itself. Now, second part is understanding correlation with other variables. That is a part of multivariate analysis that I discussed while disclosing your visualization plots itself. Multivariate analysis means understanding relation between one variable with all other variables in the dataset. How I'm understanding that? For instance, the relationship of this tobacco variable. I'll start with this. The relationship of this tobacco variable with all other elements in my data set. For instance, I have it at this position. This is my tobacco variable, and I need its relationship with all other variables. So how we can do that? You can just see this upward. If I need its relationship with your SBP variable, I can find it in relation to this element entry and the below one. This is the tobacco relation. You can observe from here. Similarly, this LDL entry at this position is corresponding to your tobacco variable right here. It means the correlation between LDL and tobacco variable right now is 0.16. That is a kind of positive correlation, although it is close enough to 0. I already told you correlation can be between -1 to +1. How one variable is related to each other, how well they are correlated, how they are, like we can say, how they are in a close relationship. Like sometimes we see that one waveform is following other waveform exactly. That means they have full correlation. And if they are out of phase, like completely out of phase, then we call it completely out of correlation, like negative correlation. So those kind of things basically we are having here. Then this variable, adiposity variable and its relationship with SBP. You just have to match these values. This one, if I link it to the x-axis with the SBP. So it means your this adiposity variable with SBP variable follows a correlation of 0.36. This is what we are understanding from a correlation matrix. Based on this correlation values, later on we make decision about whether to accept a feature or reject a feature. That is a part of feature selection or feature engineering. Correlation is one of the most important method for feature engineering. Like for instance, if two variables are following very high correlation to each other, that is beyond our threshold, maybe based on your data set you have decided that 70% is the maximum correlation I'll accept between two variables. If the correlation is more than that, I'll consider that those variables are completely translating each other, so one of the features may be redundant. I can drop one feature and I can use other one in that case. So for instance, if 70% is my threshold here, I can see here this opacity variable with adiposity variable. This shows a higher correlation of 0.72. That is indicated with this brighter color also. How we decode it? You can see the color bar over here. The higher, the brighter color goes for the higher value. This blue color goes for the lower value. This map right here will help you to decode the colors. The red one, the maximum is your maximum positive correlation. This color denotes your maximum negative correlation. So 72 is highlighted here. I can easily see this, that this is beyond my threshold. It means out of this opacity and adiposity variable, even if I drop any one, the other one will be good enough for my model training, because other is just like a redundant variable because they are almost equal to each other if I consider 70% as my threshold. In case if I consider 60% as my threshold, then I may even target this one. I'll say that my age variable is highly correlated to adiposity, so maybe any one of these feature I can use, not both of them may be required for model training. This is how we sometimes reduce dimension of your data set. We drop some redundant columns or features from the data and we use the most necessary ones to enhance model performance. This is the crux of your multivariate analysis with heat map. Just let me know if this is clear with this particular plot. Ping me in the chat box. I'll wait for the responses, then we'll switch forward. Thank you very much for those who have updated in the chat box. So this is the first plot we have seen. We'll see many more further. So let me add one more plot here. We have histograms. So we'll create here some histograms. Histograms help you to understand one most important thing that we discussed yesterday also, whether your data set is following bell-shaped curve or normal curve or not, that we have discussed yesterday also. But how we create histogram, that we will learn today. Yesterday we did that, I think, with some density plots, if I'm not wrong. Maybe some density plots we may have created, but we'll learn here specifically the histogram, and then definitely the density plot also. Both of them we'll learn right here. So I'll just choose one of the datasets, any of the datasets you can choose. I'll just choose one example. For instance, I'll use diabetes dataset. I'm exploring two datasets side by side so that you can have a variety, and you can practice also later on with all of these datasets, just to create, just to understand it deeply. So we have a hist variable or hist function directly available that we can use here. So first, I'll create a hist plot directly as it is. Let us see what we get. Then I'll add variables to this. So I have just updated a hist over here, and these are the outputs we are getting for all the variables. But what you will observe here is that things are overlapping each other. It is not clear. And if we have to put these graphs somewhere in a research paper or maybe in a thesis report, this is not feasible. So we need a clear output. In order to do that, instead of using default values of this hist plot, what we can do is we can add some parameters of interest to enhance your outcome. And that we can do. One thing we can control is, for example, number of bins we need. For instance, I need 15 bins. Maximum 15 bins means sometimes we get lower depending upon the distribution of dataset, but maximum 15, or sometime maybe like 12 or 10, anything you can put. This is a random number, like how many bins you need. And what are those bins? If anyone is not aware, you can see these slots that we have, like some bars we are getting to describe this data set. So how many bins we need? Like here you can observe 1 bin, 2 bin, 3, 4, 5, 6, 7, 8, 9. Like 9 bins it is showing by default. Similarly here also, currently these are connected to each other. We can also control the separation between these bins. The reason to represent is just to show the structure of your data. That is the only purpose. This is histogram always comes in the form of bins. So bins I'm controlling is 12. We will change this number and then we'll see the output also. Then you will be able to relate it clearly. Second thing I'll add here is figure size. Definitely that is also essential because I'm not getting a clear figure or subplots with the default parameters. So for instance, I'm adding a figure size, a random value of 10 into 7. You can change it based on how big graph you want to plot. These are the two things I'm updating first. Remaining things I'll update after. First, let us see what impact we have based on this. So this is what I'm getting. You can see the figure size is getting little bigger now. And also the second thing is number of bins. They must be updated. Although if your dataset doesn't permit that number of bins, because we have just limited to the maximum size of bins. If your dataset is not that much widespread, then it will not include all 12 bins. But yes, many of you will say that we cannot identify these bins separately because they are closely connected to each other. We are not able to separate these bins. Visualization of the bin value is not clear. So that also we can deal with here. What I'll do is I'll add here R width parameter. For instance, a random value of this I'll add is 0.9. We can vary it generally from 0 to 1, somewhere in that. So I'll add a random value between 0 to 1, 0 to 9. Now you can see little bit gap I have added between these bins, and now we can count over them, that how many bins we have in our data set. Depending upon the spread of your data, like we can have 1, 2, that is not visible here, but it should be here as a very minute value. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Because 12 bins I have described here. I need 12 bins for describing this data set. If I change, for example, if I make it 10, let us see what we get. I'll run this again. And you can observe here how I'm disclosing my dataset information. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 bins. This is just to represent your data set. How effectively you want to see the graph, that you can control from here. And the distribution, of course, will come as per the pattern of your data. That, of course, you cannot control. But yes, the bin number or size you can control from here. These are the two things I have added. Now you will observe here one more part. We have grid on these graph, and that is something like a very messy graphs you are getting, because on some graphs grid may be important, on some graph grid is not so important. Like without grid we can get more cleaner look of the graph. So that also we can do. I can add one more parameter over here, that is grid, and I'll make it false. By default, it is true. So I'll make it false. Let us see what we get. If I run this one, we'll have here a cleaner look for every subgraph. The grid is off now. This is how we can control. And you will observe here one more thing. In the outcome variable, we have only 2 bins. Reason being, for this outcome variable in your data set, if you observe, we were having only zeros and ones. Let me just see which variable we are using for this. We are using a diabetes data set, right? And the outcome variable for this diabetes data set, if we observe, that will be in the form of zeros and ones. You can see this outcome, 0 and 1. That is why only 2 bins are there. One will be on the 0 and one will be on the 1. That is basically your distribution of data like that. So we are getting a cleaner graph. Now, maybe some of you would not be interested even to see this information. Like instantly we should get a cleaner graph. So for that, I can add one more thing over here. I'll add here elements, just show the plot. No other information I need. So plot show I'll use here, and we'll update the information quickly. Right after this, we'll get the graph. Now, much cleaner, we can say. Or if still you want to add more gap between these, you can change size, like row wise, column wise, you can update your figure size. So that I'll add here 12 by 7, and we can see now a little bit gap increased between these, and on the other side also I'll increase a gap. So now you can see there is more gap between this x-axis and the next graph title. So this is how we can create a cleaner histogram. And you will, one thing you will observe, or I may just ask if any of you can observe. Can you tell me if any of these variables is following a normal distribution or not? If you can observe all these variables. If you want to plot this on your screen, then also I'll just share the code over here. Let me know in the chat box if you are observing any normal distribution or none of these have normal distribution. I hope you remember that the thing we discussed yesterday about normal distribution. I'll wait for the responses in the chat box. Some of the people are saying that we have a little bit bell-shaped curve or normal curve for the BMI. Yes, we can say like a very small level, we can say. It is little bit following bell-shaped curve, although not completely, but still we can just assume that this has a little bit bell-shaped curve. But for other majority of variables, you will see like a skewed data set. Like this one is skewed in this direction, this one is also skewed a little bit. This side is less, this side is more. So we can say that majority of these are skewed variables. So let me just get one more idea from any of you based on the concept that we read yesterday. Maybe if I have to apply outlier reduction technique on these variables, like let us consider the first variable. If I have to remove outliers from this first variable, which technique I may need to follow in comparison to the previous two techniques we have discussed yesterday? I'll wait for the responses in the chat box. This is just to have a quick idea about what we have learned yesterday also. We are just establishing the connectivity between concepts. Anyone else? I can see just one response. Okay. So I can see that those who are replying, they are just understanding the concept well. Definitely we need IQR range based method to detect outliers in this pregnancies column. Reason being, this is a skewed one, this is not following normal distribution, and this is the concept we have understood yesterday. Now, I told you that there are so many ways to visualize your dataset. We are just learning different techniques. It is not like you may have to use all these graphs in all the datasets. But since in this session, the target is to understand data visualization and EDA, we'll just try to explore different ways to do this. And let me add one more way out for the same thing. Maybe if you don't like to get histograms for your variable distribution, we can try one more plot, that is density plot. That is also similar kind of the information they will deliver, but instead of getting bin graphs that we are getting here, histogram is in the form of bin graph. But in case of density plot, you will get something like a line chart, a simple line showing the outer edges of your distribution. So sometimes people recommend density plots more. So what we'll do here is I'll add one thing. For instance, on the diabetes dataset, again, I'll be doing this analysis, or you can try on the other one also. On the diabetes data, I'll use plot command directly. And this plot command allow you to create different types of plots. The first one I'm trying here is density plot. So kind is my first variable that I'll pass, or the first parameter into the function, and the kind is density. This is type of plot I want to create. Later on, I'll show other plots also that are possible with the plot command, that plot function we are using over here. So kind is density first thing. After this, we need to pass information about subplots over here. For instance, if I try to plot it as it is, let us see what we get. If I try to plot it as it is, you will get something like this, where all the variables are plotted over single graph and we cannot observe them, definitely, because they may be overlapping each other. Some of them will be on very high nodes, some of them will be on very low scale, so they may be dominating each other and nothing is clear from this. So definitely we need to plot them separately to understand their individual information. This is a kind of univariate analysis also we are doing, because we need individual information about density distribution of every plot over here. So definitely we need to turn on subplots inside this function. This is by default false, but I'm making it true so that I get subplots for all the graphs. Now, when I'm creating subplots with the plot command, I need one more thing, that is layout of my figure, because subplots will be arranged somehow in a specific manner. So for that, I'll pass one more parameter right here, depending upon how many variables I have in this data set. If you remember, we have seen the shape method already on diabetes dataset. Can anyone recall how many columns we have in diabetes dataset? Just put it in the chat box quickly. How many columns we have in the diabetes dataset? Yes, we have 9 columns in the diabetes dataset. So if I have to arrange that in subplots, I can have a layout of 3 cross 3. That will be enough to arrange 9 plots. 3 cross 3 means 3 rows and 3 columns in my subplots. A layout of your subplots 3 cross 3. So if you have more variable or less variable, you can decide the layout accordingly. So these are the parameters I'll pass. Now, next problem we'll have with this plot command. It requires you to pass information about subplot, like how they will be adjusted. First, let us try it without adjustment. Let us see what we get in the output, how clear it is. This is what we are getting by default, without adjusting the subplot. In the previous command, in the histogram case, we had that option to adjust with figure size directly. This is just how with different functions you will have to pass parameters. With this hist command, we have direct option to adjust figure size right here. But when we have this plot command, we have to adjust subplots separately by using subplot function, adjust function. So what I'll do here is I'll add one more small task, set the spacing between subplots that we can do. Plt dot subplots adjust function I'll use. I'll take it from matplotlib and I'll update this right here. And inside this, we can pass several parameters. Few of them I'll use. Just margins we have to adjust between graphs, on the side, on the top, on the bottom. That all those things we have to update. And we put that in a sequence right here. Left margin, I'll add is 0.2 for instance. Bottom margin, I'll add like maybe 0.1 right here. Then right margin I'll add is maybe 2, some random values you can try as soon as you get the best one with your graph. Top margin I'll add for example 2, and then maybe width wise space between the graphs I need to adjust is 0.4 maybe. And similarly, one more element is your height wise space. I will be adjusting 0.4 again. All the margins I have updated here for my subplot adjustments. And lastly, we know that in order to remove this information, what we can do is, if anyone remember, what we can do to remove this information from the execution. Yes, plot show will do. That's very good. So we'll add here plot show command and I'll run this. Let us see what we get in the output. You can observe this is the outcome we are getting. These are the density plots we are getting. Depending upon the distribution of your data set, you will get different outcomes from this. So how well spread your data set is, accordingly, the distribution may change. Sometimes we have like a very widespread data set that may have a specific type of distribution. So this is just a quick density plot you are getting. Some of the data points are centered across zero, some are centered across other details. You can check this with different data sets also. That is also possible. Like for example, SAHD data set I want to try. I'll run it on that also. And in that case, maybe the size will be larger. Okay, it says that there are 10 variables, and in order to update 10 variables, maybe I can try 2 cross 5 layout I can change. Let us see. So these are the graphs for the other one. I have used 2 cross 5. You can change, you can update accordingly. The density plots you can have like this. So any of the data sets you can use with the density plots also, whatever seems feasible for you to display your data information, that you can try. I have added here in your snipper window also this particular plot. All of you can just run it and let me know if you are getting the outcome. That's great. Thanks for the update in the chat box. So we have seen the density plot right now, and next to this, we'll try to update one more, the box plots. Yesterday also we have seen box plot. That was by using a different command. We have used different techniques over there. Today we'll use it with the plot command, just to learn how we use the similar kind of approach as density. So let me show you a quicker way to do this. What we'll do is we'll just get this code as it is. The previous code will get as it is, and I'll show how we make a simple change over here. So instead of density, I'll use box over here. Means the type of plot I want to create is box now. And layout you can keep as it is, or opposite also you can try. Let us see if I distribute it in different row and column sequence. Let us see what we get. So these are the box plots I'm getting for my data set. You can see all the variables are being plotted here with the box plot entries, and just get a quick reference from this particular. Then let me know what you observe in this outcome, what you observe from the box plots that we are getting here. Any of you can just jot down your observations from this based on whatever we have understood in these two sessions by now. I'll be waiting for the updates in the chat box. So we can see some observations in the chat box now. It says that range of values accumulated in upper half, most of the values fall in that range. And some say that alcohol and tobacco have many outliers. That's great. In box plot, I do not understand this answer. Yes, in the box plot, we are trying to make observation that I'm asking you for. And some of you are right that we have some outliers in few of these variables. We can see on the upper half there are some outliers here also we can see outliers in the upper half of the box plot. For the LDL variable also, the adiposity variable is clean, we don't have any outlier in this. Similarly, this spam haste variable is also clean one. This typia, this one has some outliers on the bottom side. Alcohol variable also have some outliers on the top side. Obesity also have outliers on both sides. Age column is clear and class column is also clear. So we got a quick reference about outliers in your dataset. I hope this is clear for everyone. Those who are still looking for the snipper link, I'll just put it again in the chat box right here. So after this, let us see a few more plots in your system just to visualize your data set that we can do. So what I'll add here after box plot is, we'll try a count plot. Count plot is again one important thing that we can have. And we especially try that with class variables or categorical variables. Count plot is more recommended for the class variables or categorical variables. The other plots that we have seen already, like your density plot, histogram, they are more preferred for the continuous variables. These are the recommendations generally we follow. Okay, the first thing I'll ask here, first I'll add the task here, create count plot for categorical or class-based variable. Now, the next question I'll ask you people is, for instance, I consider my diabetes dataset that we have right here. Can anyone let me know which one of the variables out of these I can consider a categorical variable or a class-based variable that I can choose for count plot from this diabetes dataset? Which one of these I can choose for a count plot? Anyone in the chat box? For which one of these variables count plot will be suitable? Any idea, any random guesses you can have? Everyone, just be responsive in the chat box. We need to interact just to discuss things, to learn more. This is the only way for me to know if you are listening, if you are implementing, and if you are getting some doubt, so that I can explain in detail. Do we need to do anything to handle or remove outliers? That you can do later on, ma'am, because this thing we have learned yesterday, so you already know how to do this. You can try it later on. Currently, we are mainly focusing on visualization techniques, so we will not be doing any pre-processing or data cleaning today. That you can try later on based on your yesterday's learning. The main task for today is to handle visualization and reporting techniques. So I'm just discussing various visualizations here and how you report information from those visualization. That also I'm explaining to all of you. So I'm getting different responses in the output, maybe insulin, maybe age, but see, I'm talking about a class variable or categorical variable. Yes, now I got the right answer. That is your outcome variable. You can clearly see that this has two classes, 0 and 1. Means either the person is diabetic or not. So 1 may be representing one class, 0 may be representing other class. This is the most easily visible categorical or class-based variable. Same in the other data set. Maybe I want to consider this data set. Tell me which one or any of the variables you can observe that it looks like a class or categorical variable. One you can identify definitely from the name itself. And yes, one more good answer I got is this FAMHIST. This variable also shows a categorical information or class-based information with class 1 and 0. The class variable, this dedicated variable shows a class type variable or grouping type possibility with 1 and -1 variable. So any of these variables we can use for the count plots, or in the simple terms we can say that your outcome variable or the class variable or the FAMHIST variable can be better described in terms of a count plot. And how we do that count plot? We can take help from SNS, that is your Seaborn, and inside this we have directly the count plot function available. Inside this, I'll pass my x's value. On the x-axis, for instance, I'll just put my diabetes data, or means the exact information I need for the specific variable that I'll add here. From diabetes data, I need to focus on outcome variable to create my count plot. That we are doing here. So I'll just run this part and we can see the count plot right here with zeros and ones instantly. Means what it is telling us basically, how much values of zeros and ones you have in your data. So it shows that your zeros count is almost 500 and ones count is somewhere around maybe 260 or 270, somewhere it may be. So that quick information about if you have equal number of observations from both classes. And this introduces you to one important terminology in your data, that is imbalanced data set. Understand this fact very carefully. Imbalanced data set. When you don't have equal number of observations in both target classes, since outcome variable in this particular data set is a target variable, we are trying to predict this variable only to understand whether the person is diabetic or not. And if it has a distribution like this, means the zeros and ones count is not approximately equal, rather there is a big margin. So this becomes a kind of imbalanced data set. One more observation, one more report you can generate from this to add into your thesis or in your research papers, that the data set we are dealing with is a imbalanced kind of data set. And there is a different treatment that you may have to follow while building a model for an imbalanced data set. Although we are not going into that part right now, since we are understanding the visualization in this session, but still I have introduced you to the uh, outcome of this particular code or this particular count plot that we have received here. I'll share this code with all of you as well. You can plot it. This count plot again we can use in variety of ways. Sometimes we use it to understand individual variable. Sometimes we even use count plot to understand a relationship between two variables. So in case of that, when we have like this information between to share between two variables, preferably both your variables must be class type or categorical type. Then only we can understand relationship between them, because we already discussed that count plot is for categorical or class type variables. So we can see that in your SAHD dataset, we had two variables that were class type. So that we can observe right here. This famhist and this class, two variables we can use for establishing relationship between these two elements right here with the help of count plot. So what I'll do is I'll use count plot in other way here. I'll add this and SNS dot count plot again. I'll insert x is equal to SAHD underscore data, and the data first element I'll use is class element. So if I use information up to this, we'll get a graph for the class data only. Zeros and ones, or one or minus one count that we have inside that will be represented. Second variable I'll add here is hue. That will manage color of my graph based on another parameter that I'll pass here. And that parameter I'll use is the second element that we had, second element of interest that we had, your famhist. This was the second variable of interest. So main variable is this, and color coding of this I'll do based on the famhist variable distribution. So let us see what we get in the outcome. I'll just run this part and you can observe I can code it into two sections now. This famhist automatically became a legend in your graph with the color coded information representing zeros and ones. And for the class variable, we got the two classes automatically. So it says that from class -1, we had this distribution of famhist. In class -1, the famhist zeros and famhist ones are with this distribution. And in class 1, the famhist zeros and ones are with this distribution. This becomes a kind of your bivariate analysis. We are just trying to understand relationship between two variables right here. So let me just put this in the snipper window as well. All of you can try this. Maybe on some other data sets also later on you can try this. So in the meanwhile, how image data can be used for visualization. For image data sets, the procedures are generally different. Currently, we are doing it with the CSV data sets. Image data sets, generally, you don't need to use this kind of visualization. Very rarely it will be required. But still, if you need, then in that case, sometimes we derive features from the image pattern, because image patterns are generally in the form of very big matrices, like 1,000 cross 1,000, 10,000 cross 10,000, or 1 lakh cross 1 lakh. Very big size of matrices you will get from that when you extract the pixel information. So it is rarely required to create these kind of plots from the image data. But if you still need, we derive some features from that, those pixel values, such as some statistical features like mean, median, or mode, etc. And many other features are there on the statistical grounds. And then we can create plots based on those features further. So that will be a secondary analysis you can make from your data set based on the requirement. Not these kind of plots you will require in case of image data. So let me know when we all are done up to this. Then I'll proceed ahead with one more kind of EDA right here. That will be one more plot we'll learn. Again, one important part is with line chart. And these line charts are widely used for, again, continuous data set. We are just trying to see the mixture of variables. So this time we'll do it for the continuous variable. And again, line chart can be used for univariate, sometime for the bivariate analysis. In different ways we can use it. Currently, I'm going to set it up for your univariate analysis, and I'll use just one variable from the dataset. For instance, from the diabetes dataset, we'll use like one continuous variable that can be maybe age variable we can use. So I'll add here line chart for continuous variable, and that variable name is age in diabetes dataset. You can try with any other variable also. It should be just continuous in nature. Any other variable also you can try. What I'll do here is, again, I'll use plot command, but I'll add a few different parameters for a cleaner look. We have seen that we can adjust plots as per our requirement to get a cleaner look. So I'll add different elements over here. I'll share the code. First, understand what we are doing here. First, figure size element I'll add is 15, 7. Figure size element I have added. Then I'll create my plot element, and inside this plot element, I'll use my data age, data diabetes, and inside this I'll pass age parameter. And we already know that there are a huge number of observations in this age parameter. Like if we just see the size of this diabetes data set, if you remember, we have already seen the shape of this. There are 768 observations. So the line chart may become very messy in that case, although we can try, but that chart will become very messy. We can even control that. First, let us create it as it is with full observations. Then we'll try to control its outcome. First, let me just create it with this information only, with a very small information. I'll do it here. Let us see what we get in the outcome. You can see this is my graph right now. So on the top side, you will see the age. This y-axis is by default representing my age information. Sometime we can change these axes also. I'm not going so in depth with that. You can later on see that easily. I also give you some sources how you learn additional elements while discussing further things. But initially, it will take the by default values. So on x-axis, you will see the number of observations, because we have 768 observations. So somewhere at this point, it is observing the count. And on the top side, it is showing the age. Maximum age may be somewhere around maybe 86, 87 somewhere. So that it is showing right here. But this is like a messy plot, although it is giving you exact information about age, that how the distribution is going on. But sometimes we may need partial information, like a specific portion of the data we want to sample to see a line chart. That is also a requirement sometimes. Like maybe you have maybe months of information, and from that you need to plot it for a specific week or a specific month. You can even slice information based on that. I'll just give you a mini example of that. Later on, you can try different approaches also. So I'll control the parameter count, maybe from value 100 to value 251. We can try different values right here. And what it is, if anyone can recall from yesterday's observation or from the general Python concept, if I write here 100 to 251, what it may represent? Anyone quickly in the chat box. Yes, so this is from hundredths to 251 row. Start from 100th index and go up to 251 index. So just some minimum set of values we are trying to print as a line chart over here. So let us see what we get. I'll run this part and let us see what we have as an outcome. You can see from 100, it started from hundreds observation and it ended somewhere around your last value, that is 251. Right here we can see. So this is how we can even control what we want to plot. One more thing. Now, this plot right now doesn't have any axis information. So if you try to put this kind of plot in your research papers or in thesis report, the first comment from the reviewer or from your guide you will get is like, why you don't have the axis information? How I'll understand that what is represented on the x-axis or y-axis? So let us make it clear. We'll add few elements over here to make it cleaner. First is I'll add a title element where I'll write patient age information. And for instance, I'll control its font size also. Some elements we can pass as per the requirement. Maybe font size I'll keep 12. Many other things also you can control. I'm just giving you few examples over here. X label I'll add is patient count or observation, anything you want to put. Similarly, Y label I'll add is age. That will describe my plot in a much finer way. So if I run this part, what we get in the outcome, you can see patient age as my top portion as a title. Here on the y-axis, we can see the age now, and on the x-axis, we can see the patient count from 100 to 250 or 251 that we have. So this is for a finer look of your plot, because charts are always required with specific axis values. That is the only good way to represent any kind of chart. So that we have just learned how we add it. Let me know when you all are ready with this plot and you have got the idea what we are doing here. I'll wait for the responses in the chat box once you are ready up to this. Are we done up to this? I cannot see any responses in the chat. Okay, thank you very much for the update. So the next element I'll add here is, let us create a bar chart. Going further with your exploration of data by using a bar chart, I'll use it on the same variable, like this age variable I'll use, because there is one way is with line chart, and we can do the same with the bar chart also. And plotting a bar chart should be very easy. We can even style it as per our requirement. First, I'll create it with basic information, diabetes data, and from there I'll choose my age variable. You can try with the different variable also. And I'll pass one more parameter, that is 100 to maybe 151, any range you can use. Then plot, here I'll add up bar type plot, and inside this I'll add figure size information, that is 15,7. Let us see what we get in the outcome of this. I'll This information I need to put in specific brackets for the figure size, and one more I'll close right here. Let us see what we get. This is the bar chart I'm getting now. You can see now in the form of bar graphs, I'm getting the same details. You can upload all the plot information that we already know, so I'm not updating it again. We know that we can add x's information, x label, y label, all those things you can add. I'm just creating the different version of the graph for you. This is without grid. You can also add grid. For instance, if you need grid, because sometimes for these kind of bar chart, if you need to compare the value exactly with the y-axis value, you may need grid in that case. So this is how your grid may be useful in some cases, it may be unuseful in other cases. So that we can add here. Plot style use, and Seaborn white grid I'll use. There are many other ways also. I'm just using one sample over here. White grid I'll add beside my this. You can see now I can compare it easily, that this is approaching 60 or this is approaching little less than 70, and similarly this is somewhere below 50. So we can say it clearly now with the white grid behind this. So sometime a grid may be useful based on what type of analysis we are doing from the data. Let me know if we are all done up to this. So after this, I'll add one more way out for exploration of your categorical or class-based variables. One technique we have studied is count plot. Other we are using is pie chart. Pie chart is also suitable for your class-based variable. Pie charts we are using in mathematics also commonly. We know that this is just to see how much count we have in one class, how much in other class, that we can create right here also. So a simple way, there are several different ways to create these plots. Even for pie charts, you will find plenty of different codes that are possible. I'm using just one sample over here. For instance, from SCHD dataset, I'll use a group by technique. Definitely, you will find many other ways also. Group by class for my pie chart. I'll use size parameter because size of both classes we need specifically to plot that graph so that we can see the distribution clearly. And then I'll use plot command with kind is equal to, this time I'll pass pi because we need a pie chart. Then we have text props. Inside this, we will pass first element is font size, will pass 14 to this, and second is auto. Okay, I'll pass this later on. First we will see only these things, then I'll add one more element inside. Let us run this one and we see this in the outcome. -1 and 1 distribution, a clear pie chart we have over here. But there is one more thing you may need. The percentage information that is more relevant in a pie chart. Whenever we create it for mathematics also anywhere, we just try to get number of counts or the percentage of every section of the pie chart. So that is very easy to add here. We have a technique called autopect to update that percentage information. So I'll add percentage information with one decimal point value. This is the format we follow. This 0.1f represent how many values I need after decimal. That will be one value in my floating point representation. F represents a float. So percentage analysis I'll show in the term of floating point variables with one value after decimal. So if I run this part, let us see what we get in the outcome. You can see clearly the percentage analysis in both sections with one decimal point value after this and the percentage sign also added into the sequence. So I'll copy this part and we'll update this in the snipper window. You can all create a pie chart for any other class-based variable as well. Let me know if we are clear up to this. Which graph you are not able to see? We have wide enough graphs over here. Unable to see the graph. Why? What may be the reason? We are getting a very specific figure size for all the graph. Just the last graph you are not getting. Please see if you are following all these settings as per the requirement, and if you have not added anything specific in your code, because by default this will come like this only. You can try rerun it again and see if you get the outcome like this. There should not be any change. Others can respond if you are getting the same pie chart. It is visible clearly or not. Okay, so others are getting it same. Sir, please check if you have made any other setting somewhere, because otherwise we have not added anything that may cause display issue for you. Okay, so we are done with the pie chart also over here. All of these plots are the basic plots that we have created. These days, people are also using some interactive plot options where we can enable, disable the different things. So that option is also available. I just tried to create, depending upon how much time we have, one or two of such interactive plots I'll add over here. For instance, with that enable, disable option, if you want to add something, I'll add here interactive plot using Plotly. Plotly is another plotting library. So for instance, I'll take help from Plotly over here and let us see what we can create. First, I'll have to import my Plotly dot express as px, the library module I'm just calling here. Df, I'll be using one by default available dataset, that is iris dataset. We also have it in the folder of yesterday's folder. You can get it from there also, although it is available by default also in your Plotly library for initial analysis. So from Plotly library itself, I'm calling iris dataset. Then I'm creating a figure right here, px dot scatter. Inside this, I'm passing df variable, then x is equal to, for example, we have sepal width. These variables we have seen yesterday that we already know from the iris dataset itself. Then second variable I'm passing here on the x-axis, I'll keep sepal width. On y-axis, for example, I'll keep sepal length. And then color I'll pass from the species variable in my dataset. These are the columns we have in this particular dataset. So that I'm using to distribute, to show the distribution of this particular dataset. Just a quick way out. Figure.show I'm using here for this recently created figure. In Plotly, we use it like this, and then we can see outcome like this. This is the distribution of sepal length with respect to sepal width, and the color distribution is from the species. You can see right here. And now there is one interesting part. We can even enable and disable few of these elements. You can see I can disable this green one, Virginia Nica, and we will not see the green outcomes over here. I can disable any other also, and then we will see only one. This is a kind of interactive plot. I'll disable this one also, and then we have the empty graph. I can enable again, we can see the green one distribution. So with reference to specific element also, sometime we can do this kind of analysis on a single graph. This is these are like some interactive features we have in different libraries. There are again unlimited ways to do this kind of thing. You can try so many varieties, you can have so many things that you can update as per your requirement. So this we have just obtained quickly. Let me know if you all are able to plot it. I have shared the code in the snipper window. I'll wait for the responses in the chat box. We can even get maps from different locations if we know the location information, longitude, latitude of that location. We can even display maps directly on this Google Colab platform by using Python code. So if you want to see one example of that, let me add over here. That is also a part of data exploration for maybe if certain location you want to track by using a map. Interactive map with, there is a library called Folium for this. With Folium, for instance, we want to add. Now, first we need to import Folium for this. I'm not giving it any nickname right now. I'm using it directly. A variable m I'm using here. You can give any variable name. Folium.map function I'm updating. Inside this, I'll pass location information in the form of longitude and latitude it will ask. So I'm just choosing one sample information over here, for instance, for San Francisco. You can enable it for any other location also if you know the longitude and latitude information. So I have just gathered one sample over here that is with these location IDs. I'll share this also. So for instance, this location information I have added, and I also need the marker on the graph. So that marker will start with the initial value of your location right from here itself. I'll update it, and then I'll just pop up the name of the location that I'm updating over here. San Francisco I'm updating, and I'll just add this marker information to my figure M. Quickly, I'm adding this element right here. After this, I'm just plotting this M element. So this we can update right here. You can see in the outcome this particular graph. I can share this in the chat box. You all can plot it and let me know the outcomes. So this information you can put up for any kind of location. If you need have the longitude latitude information, you can just add that. You can update the name for the markers, etc., that we can highlight over here. A quick info we are getting from this graph, and this is an interactive one. We can even scroll through this, like you can see the marker you can place accordingly. So this marker we have placed on San Francisco right now. You can put it on any other place also, and then accordingly the marker, this marker will be changed to that location, and your longitude latitude you can provide accordingly, and we can scroll through this information quickly. This is a way to get graph. Let me know if you all are done up to this. No module named Plotly. If you are getting it, then you may have to install Plotly. Those who are not able to get Plotly directly, just run this one command, pip install Plotly. Before running this code, run this particular command, because in your case, you may have to install first. In my case, it is installed already. So that is why I'm able to import it directly. In your case, you may have to run this. So just run this command and it will import Plotly like this. I'm doing this version is not matching because mine is getting from the default one. Okay, let me know if anyone else is facing same issue. If Plotly is available on your system or not. Are you able to get this particular plot? Because this generally comes by default. We need not to install it. That is why we are getting an error over here. This will come by default with your system. Anyone able to plot this particular graph? Yes, it is working fine with Plotly. For someone, maybe it is not working. Maybe some settings are changed on your system, or some issue may be there. I'm not sure, because this generally comes by default. You need not to install Plotly separately by using pip command. So maybe you can refresh your sheet. You can open it again and then try. Maybe it will get all the variables again. Sometime we get issues on the server also, since we are working on Google servers right now. So that may be also one reason. So this we are getting with two interactive plots we have added here. And one last thing I'll add to this EDA and reporting technique we have here is one data report or data prep technique also we can follow to get a quick report about all the stats of your data. So I'll add here generate full statistics report by using data prep library. One more important thing, how we get a complete report for your data by using data prep. There are unlimited such libraries again in Python. One of them we are trying here, that is data prep. And this data prep will not come by default on your system, so you may first need to install it. So what I'll do here is install data prep. And to do that, again, I'll use simple pip command, pip install data prep. This I have to write over here. Let me run it. It will take some time since it has so many packages. So it takes some time to update all those packages. And all of you can try this side by side. I'll put it here. Get your data prep library ready on the system, and then we can try to create a report that we can do quickly. Very simple process we have within data prep to generate entire report for a complete data set. It contains several essential elements. So you can see it is putting up all the dependencies aligned with your system, whatever we need for creating this. Okay, it says we need to restart the session in my case. So let me just restart it. And in that case, we may lose the variable also. Let me just check. If you all have restarted, just do one thing, run this part again, and then load datasets again. Maybe after refreshing, you may have lost your variables. So two commands I have rerun here, and then I'll see if my data prep is working directly or if I need to import it again. We'll see that. First, I'll just put my code right here from dataprep.eda, because this reporting is also a part of EDA itself. So I'll use EDA module from data prep, and then I'll use create a report function directly. And this I'll pass to my specific data variable, for example, SAHD data. This is my variable. So if my data prep library is ready, then it will run. Otherwise, I may have to reinstall it because there was some runtime issue. So I'll run this part and let us see what we get. Yes, it is able to generate the report without any error. So data prep is ready on the system, and I can share this code side by side with all of you. Yes, the report is ready on our screen. First, just run this, then I'll show you what we have out in this report, what we are getting with this particular report. Let me know when you all are ready with the report on your screen. I'll wait for the responses in the chat box. Okay, no problem. I'll wait for the 5 minutes. If anyone is getting any kind of error, they can also let me know in the chat box. How many of you are able to get this report? At least they can let me know. Great. Thanks for the update, sir. That's good. Anyone else who wants to report their outcome over here? Let me know when we are ready to discuss this report. I hope we are all connected. What to do if pip install is not working. I'm not sure what error you are getting. Generally, we put this exclamation sign in front of this. It should work. Pip doesn't have any specific error. Just a syntax error you can get if you are not using it in specific case sensitive manner. Or the last thing you can try is you can just restart your session from here and then try it. If maybe something is wrong with your server, it is not connected well, then that you can do, because pip is a very basic command. You will rarely find an error with this. So this data prep we have generated over here, and let me just quickly give you an idea about the report that we are getting. Quick data statistics we are getting from here. For instance, the number of rows in the variable, number of columns, any missing cell information, any duplicate rows, total size in terms of memory capacity that we can have over here, and then variable types, numerical and categorical, that also we are getting. Dataset insights about skewed and non-skewed, that we have seen with those graphs also already. It was majority of these was skewed and a few were having constant lengths, so that we can see right here. Similarly, we have individual variable distribution as well. So you can see this histogram kind of plot we are getting with specific bin sequence, and we can even mark on specific values over here. We have for each individual variable statistical analysis is provided here. If there is a specific count, percentage of count, mean, median values, etc., presence of zeros or negatives, that initial information for every variable you will get. If I scroll through this, for every variable you will get this information. You can see the count plot. This is how quickly we understand that which plot is suitable in which section. We have tried all this already, but there is a quick method also to get everything done in just one command. This is just some easier way to do the same thing. So we are learning both things. Sometimes we need just one plot, sometimes we need entire report. Accordingly you can use, you can just explore all the variables over here. Then we reach the interaction part. Here we can interact between two variables. So currently it is interacting with the individual variable. On the x and y axis we have same variable. We can even change, like if I want to see relationship of SBP variable with the class variable, I can see it like this. It is distributed like this. On the one side and on -1 side, this type of observations I have. Similarly, maybe with the age variable I want to know, this is the distribution. A kind of scatter plot basically we get from this interaction. Then correlations. I told you that there is generally one triangle, upper or lower. So by default, they follow lower triangle over here, that you can see with the color coding right here. There are three different types of correlations. By default, we prefer Pearson. The one correlation method that we have used, that also use Pearson by default. Other are Spearman correlation and Kendall correlation. Any of these you can try and you can experiment. Generally values are close enough, not a very big difference you will see, but yes, these are different methods that you can try. And missing value analysis, currently we don't have any missing value in this, so we have all the blue. If there are some missing values, you will see that with this orange marker also in the set. So these are the essential elements we are getting within this report. You can even get a printout of this report. There are many other things you can do. Currently, we are discussing it up to here only because we are on the verge of first session. So I'll stop right here with the data visualization, EDA, and reporting part.